So basically here written in the principle, the qualitative test is one of the earliest identification or chemical analysis which can be done on an unknown organic sample. Back when there is no instrumentation or this analytical instrument available, um, they used to test using wet chemistry, meaning using reagent or using other chemicals and doing reaction in which to determine the identity of the organic compound. But with current technologies, we can actually in a real lab, they won't actually do this kind of test if they have the instrument. For example, we can determine the functional group straight away by using the IR spectrophotometer, the infrared spectrophotometer. Using that, we can actually determine whether it contains alcohol or it has any carbonyl group whatsoever. Or in fact, we can also determine the number of carbon and hydrogen available by using NMR, nuclear magnetic resonance, whether it is proton NMR or hydrogen NMR or carbon-13 NMR. We can specifically determine the exact number of the hydrogen and carbon present. So, but for beginners, it is good to actually grasp the basic analytical way in which that you have to do it using reagent, doing reaction, in which that the observation has to be done mainly with our eyes, or it could be using the sense of smell. So there are here written there are hundreds of qualitative tests that can be done to characterize or distinguish the functional group in the unknown substance. And what have been listed below is just some of it. You can refer to a what you call organic experimental textbook. Okay, there are many which it will be there are like here it said hundreds of tests, mainly if you want to test for specific functional group, or if you want to test for specific presence of heteroatom like nitrogen or halogen available. Okay, but here I have selected a few tests to be included in this practical, so that it how to say um, covers or reflect what you have done, or some of the functional group that you have done in theory class. Okay, so the test is mainly divided into one, two, three, four different groups. Okay, in which that we have the preliminary analysis, or we can also call this as a physical analysis test. And then the second one would be test for saturation or unsaturation. The third one would be the aromaticity, or the aliphatic nature of the compound. And the last one would be the test for functional groups. Okay, so we're going to look on the preliminary analysis first, or the physical test. So basically, the unknown, or the sample given to you, okay, the unknown organic sample could be either in solid or in liquid state. Okay, so it can be in solid or in physical or solid physical state. So what you have to do when you receive the sample, you can check for the color and appearance. Okay, and also to analyze the odor or the smell of the compound. So here listed are the observation and also the inference, or the we can say like what is the expected outcome from this observation. For example, based on the color and appearance, you see that it is a colorless liquid, so it could be a hydrocarbon. So hydrocarbon is very general, okay, and then colorless liquid, so it could be hydrocarbon, it could be an aldehyde, ketone, or an ester. If you see that your sample is a yellow solid, then it could be an aromatic nitro compound. So this starts to become a little bit more specific. And dark brown liquid, it could be an amine or phenol. So here, it is not actually a very specific, you can determine straight away. Okay, by using physical tests, it is more or less trying to narrow it down into what kind of functional group test later on that you want to do. Let's say it is a yellow solid, you might think that it is an aromatic nitro compound, so you can straight away do a test for aromaticity and also to check whether it contain nitro group or not. Okay, instead of doing all of the tests before going through the nitro group, for example. And then in terms of smell, okay, so these are the general smell or the generic smell for the whole hormone series or for the whole functional group series. Okay, some of it might have slightly different, but overall, for example, for an ester, the smell that you would tend to actually get is this pleasant fruity odor. Okay, that is for ester. And then for an amine, it will be those fishy odor. And then for phenol, it will be carbolic. And then if you smell your sample a little bit pungent, then it could be an aliphatic or aromatic halogen compound. So compound or hydrocarbon that contain halogen. And spirituous, so it could be alcohol. So lower alcohol meaning ethanol, methanol, propanol. So those are considered to be lower alcohol. And then smell of kerosene-like odor or camphor. So this could be aromatic hydrocarbon. And the last one is like bitter almond odor. So this could be aromatic aldehyde or nitro compound. But then again, this odor test or the smell test could be not really that accurate, as you cannot actually describe a smell. If I were to describe a smell to you that I think this smell is sweet, so how to describe a sweet smell to another person, right? So we tend to have different perspective of smell. Okay, for example, like an ester, even though the generic smell could be said to be pleasant fruity odor, but to another person, okay, maybe one of you think that it smells pungent. So this is this test, which is the smell test, in my personal opinion, it's not really that accurate, because we tend to have different views in terms of the smell. And I, for once, for my personal experience, have slightly different sense of smell than other people. Okay, when I was doing this in my undergraduate, so all my friends said that it is like pleasant fruity odor, but I tend to have different kind of smell. So maybe that's just me, but then again, it is not how to say an accurate test, but if the majority of the person who smell it said that it could be it is a pleasant fruity odor, then it might be an ester. So you might as well do the ester functional group test later on, instead of doing aldehyde, ketone, alcohol, for example. Okay, so that is on the physical analysis. So you just do two, which is the color and the appearance. You check that, and also you check the smell or the odor of the compound. And also, when you want to smell the compound, okay, normally the sample will be placed in a test tube. Okay, so later on, all of the tests will be done in a test tube, because for qualitative, the amount is not important. It's just that the outcome. Because qualitative, we just want to see the what you call that, probably the observation, maybe the color changes, or there could be precipitation happening. Okay, so we are not going to quantify it. So normally the tests are done in small volume or small scale. So it is just done in a test tube. So when you want to take the smell of the compound, you don't straight away like take the test tube and place it uh, under your nose, okay, like really smell it. We use the term as taking a whiff. So you take the test tube or the glassware that contain your sample that has been placed in, and then um, just sort of like using the other hand, trying to fan out the vapor or whatever smell that comes from it to your nose. Later, there will be a video that I'll show on how you are supposed to actually smell the compound. Okay, because you are not going to actually uh, take it straight under your nose, because you never know whether the compound is harmful or hazardous or not. So it is not advisable and not a safety practice to do that. And then for the second test, it would be on the test for saturation or unsaturation. So this is to check whether the compound is saturated or not. So unsaturated compound will contain either a double or triple bond. So saturated compound doesn't contain any C double bond C or C triple bond C. So there are two tests in which that you can do. We have the first one, which is the bromine water test, okay, and another which is called as the Bayes test. So below each of the tests, there is the procedure, meaning what you have to do the test. For example, like test with bromine water, you just add 2 to 3 drops of bromine water to your sample and shake well. So probably in your test tube, there will be 1 or 2 ml of the sample, and you just add 2 to 3 drops of this bromine water. Okay, the bromine water will be ready, meaning it is already prepared, so you don't need to do anything, because all of the tests are mainly done by mixing your sample with reagents. So you straight away mix sample with another reagents and then check for observation. So if you mix your sample with bromine water, so there could be three what you call observation that you might expect. So the color of bromine change. So this could be an unsaturated compound. No decoloration. No decoloration, that means the color remain the same. So it could be a saturated. And then there is decoloration. Okay, the color of bromine change with white precipitate occurring. So there is color change and also precipitation happen. So that could be an aromatic amine or phenol. So the color of bromine change, I did not specify the what color to what color, for example, because the bromine water is generally like brown, okay, or yeah, almost brown or slightly dark yellow. So it depends on the type of reagent, because different from different chemical company, the bromine water color would be slightly different. So if you see changes, meaning let's say from dark brown to, it could be, doesn't have to be colorless. If it is colorless, that means all of the bromine that is in the bromine water is fully reacted with the sample. What you have to see, you are supposed to see here is the color of the bromine water change. That means it could be from dark brown to a slightly pale brown, or it could be slightly paler than the original. So that is considered to be color change already. So you might say that it is unsaturated. It doesn't have to be fully colorless. So if it's fully colorless, that means all of the bromine would be uh, reacted. Then you have this Bayes test. So Bayes test is mixing your sample with here it is stated as 3 drops of Bayes reagent and also 1 ml of water. So Bayes reagent is actually alkaline potassium permanganate. So the potassium permanganate solution, but already turned into slightly alkaline, so or slightly basic. So normally the potassium permanganate will be mixed with a little bit of potassium hydroxide or sodium hydroxide to it to make the solution basic. But as the boiling water earlier, the Bayes reagent also will be straight away coming out from the bottle. We can straight away buy, no need to prepare. So you mix it, and the observation, the pink color is changed or no decoloration. So based on this, you can make an inference or deduce whether it is saturated or unsaturated. So just the two tests for the saturation. And then the test for aromatic or aliphatic in nature. So this is to determine whether the compound, if it's aromatic, then definitely going to have a benzene ring. So whether it contains a benzene ring or not. So there's only one test, which is the nitration test. But these tests use a lot of concentrated acid, okay, concentrated nitric acid and sulfuric acid. So these are to be done, if you were in the lab, these are to be done in under the fume hood, say, because these reactions generally will be slightly exothermic, as in if there is reaction with your sample, if let's say your sample is aromatic, then the mixture will heat up, okay, and there will be like very vigorous reaction happening, and in some cases it will sort of like having tiny explosion in the test tube, okay, but after a few seconds the reaction will subside actually, because there are cases okay, previously, that some of your seniors which done it outside of the fume hood, okay, and there is a vigorous reaction happening, and she got scared and dropped the whole test tube, okay, just drop it, the test tube, and because she was uh, holding it using her hand, okay, instead of using the tongue, okay, because when you want to mix the acid, we it is advised not to hold it with your hand, okay, use a tongue or use the test tube rack before adding the acid, because if anything happen, you can just leave it, okay. So she dropped it on the floor, and the acid got splashed, I think to her hand, I think, if I'm not mistaken. So to avoid all of this, so make sure do not take it out of the fume hood, okay. But you are not going to do this in the lab, but then again, just please take note, if in future you were to deal with this concentrated acid, so be very, very careful. Okay. So here for the nitration test, you have to add 1 ml of concentrated nitric acid and also 1 ml of concentrated sulfuric acid to the sample. So here it is only stated as small amount. So as earlier, it just 1 ml, 2 ml of the sample. If let's say there is a volume stated, then you have to add accordingly. But if it just said a small amount, then 1 or 2 ml will be enough, okay. So you have to add that, okay, and once these two are added to the sample, this is when some of the vigorous reaction might happen, okay, and you have to wait until it subsides before taking it out and heat in a water bath. So you have to heat the whole test tube. So it is done in a water bath and cool it down. So after it is cool to room temperature, then you take the whole mixture and pour it into a beaker of water. So then only you see the observation. Okay, for example, if this is an aromatic compound, so you're gonna find slightly yellow solid separates or yellow oil. But if there is no aromatic whatsoever, then it will just be no yellow color. Okay, no yellow color on the compound. So this is actually a nitration test or nitration reaction which is occurring under the electrophilic aromatic substitution reaction. Okay, you are trying to replace one of the hydrogen on the benzene ring with nitro group NO3. Okay, this one next semester you will learn on the reaction mechanism. But for aliphatic compound, there will be no reaction. Then after you did that, number 4 will be on the test of functional groups. So there are 3 functional groups tests for this experiment. You have to do for aldehydes, for ketones, and also for esters. Okay, but some of the tests in aldehyde and ketones are the same. Okay, but all 3 reaction for esters would be different. So let's take a look for aldehyde first. So for aldehyde, you can do the sodium bisulfite test, and then Schiff test, failing test, again Bayes test, and also tolerance test. So actually Bayes test is the same as what you have done in the saturation test. So you might use the same observation over here, because here pink color is changed and brown precipitate is formed. You see the observation, it has some additional, which is brown precipitate. So it could be aldehyde. And then the last test for aldehyde is tolerance test, or using tolerance reagent. So this is when you mix your sample, okay, with 1 ml of tolerant reagent and heating it in a water bath for 10 to 15 minutes. So the observation that you will see is either a silver mirror form. So the silver mirror is actually the silver which is Ag, because the tolerance reagent contain silver Ag ion. So the silver will end up deposited on the wall of your test tube. So it looks like a mirror because it slightly reflects. So you can actually see the silver mirror form, okay, or there is also a black precipitate. Okay, so it could be either of this or both of the observation is there. So this would be an aldehyde. Okay, so this would be considered to be an aldehyde. If it is a ketone, you will not see any of this observation. And then for ketone test, okay, the sodium bisulfite test is the same. Schiff failing is also the same as the aldehyde. The one that is different is sodium nitroprusside, okay, and also the iodoform reaction. So these two is a specific test for ketone. That means I will say this as a positive observation. That means it proves that it is a that functional group. For example, tolerance test, the positive observation is it will be an aldehyde. Okay, so sodium nitroprusside and iodoform reaction, the positive observation as in orange color is formed or orange color change to purple, so it might be ketone over here. So here for iodoform, a yellow precipitate with a typical smell is produced, so maybe a ketone. So how do you decide which functional group it is? For example, you do the test between this aldehyde and ketone for the whole aldehyde. So there are 1, 2, 3, 4, 5. So there are 5 tests. You notice 4 of them give negative observation, and only one test that you did said that it might be an aldehyde. Okay, so uh, you did another the ketone functional group test. Over here there are 1, 2, 3, 4, 5, 6. Okay, 6 tests. 5 of them, the observation said that it might be, okay, you cannot say like truly confirmed, but it might be a ketone, while one test that you do said that it is not a ketone. So how do you decide on what is the functional group of the compound? So if that kind of observation occurred, that means first you can try to redo the test. For example, like the one test that you check that might give positive, for example, the tolerance test. So redo it again. If let's say because you might did it wrongly the first time, but if it is still persists giving you positive, okay, leave it, and then repeat again the other test that gives negative observation for ketone, for example. So if the same observation is seen, so you have 4 tests as negative for aldehyde, 1 positive for aldehyde, and then for ketone, 5 tests is positive ketone, 1 test negative ketone. So if let's say something like this happen, uh, I would advise you to take on or select the majority of observation that you have. For example, here, the aldehyde test, 4 of the tests said that it is not an aldehyde, while only one said that it is an aldehyde. So it is how to say, actually to take on the majority of the observation or the inference, okay, rather than just because one of the tests said it is an aldehyde, you straight away conclude, oh, this could be an aldehyde. Same case for let's say ketone, 5 of the tests said that it is ketone, okay, only one said it is not a ketone. So the majority said that it is ketone. So you can make your conclusion saying that the compound might be a ketone, because in actual lab condition, okay, you might not actually get all the observation as stated, because all of these are theoretical. Okay, back then people do the test, but they don't just do one test, they repeat it probably maybe 100 times to say that this is the observation. We never know that out of that 100 times, it could be that 80 times only the person get this kind of observation, the other 20 doesn't get the same observation. So uh, here the observation stated is what the it is expected, okay, the majority of the outcome will be. And then the last would be the esters. Okay, there are only 2 tests. For the esters, there is no specific name test for it, but the first one is by adding 2 ml of your sample, okay, and then with 2 ml sodium hydroxide solution, heat for 1 minute and cool it down, and acidify with concentrated uh, hydrochloric acid, 1 or 2 drops. So you see what observation over here. Okay, let's say here, if your sample is in solid form, because here said as 2 ml of liquid. So if your sample is in solid, you have to dissolve it first, okay, with uh, any suitable solvent, okay. And the second one is uh, 1 ml sample, okay, will be added with 1 ml of hydroxyl amine hydrochloride, and also to be added with alcoholic potassium hydroxide or alcoholic potash. So this is basically a mixture of alcohol and also potassium hydroxide. And then you have to heat, cool, and also acidify with dilute hydrochloric acid. Then only you add the iron chloride solution. So these are the observation or the color observation that you should see. So any uh, test or any procedure that involve the addition of concentrated hydrochloric acid, okay, it has to be done in the fume hood, okay, because all the acid will be placed there. So you don't take the whole what do you call that container, okay, that contain the acid out of the fume hood, okay, and then put it on your bench. So it has to remain in the fume hood, because in the fume hood the all of the acid will produce vapor, okay, and the vapor are hazardous. So in the fume hood, all of this vapor will be sucked out instead of lingering around in the lab. So now I will show you some of the video over here. So the first one would be on the physical, okay, on the physical observation.
Today we're going to look at a series of wet chemical tests to identify unknown organic compounds. These tests are really traditional and they can tell us about what functional groups are present and also what elements are present in a compound. The first thing to look for is whether a compound is a solid or a liquid. For solids and liquids, you can often tell by the colour what sort of functional groups are present. Ketones, diketones, quinones, and conjugated species all can be yellow, orange or red coloured. Phenols are usually quite dark coloured, like this one. Sometimes though, organic compounds go off in storage and they become quite dark as they oxidise, so you can't always tell exactly from the colour. Another thing that you can do is identify the odour of the compound. And you don't want to take a very big sniff of organic compounds, but if you use the wafting technique and just slowly inhale the odour of the compound. Things that smell really fishy, quite often are amines, and things that smell really pleasant can be esters. The first step in this test is to determine the melting point or the boiling point of the compound. If you have a liquid, carry out a boiling point analysis. But if you have a solid, do a melting point analysis. The melting point will always be a range, and the size of that range will tell you how pure your compound is. So it should be within 2 or 3 degrees from when it starts melting to when it finishes melting to tell us that we have a really pure compound. The first step during your melting point is taking a small amount of the sample and placing it onto a watch glass. Compound needs to be dry to do a melting point. So if it's a little bit clumpy, put it in the oven for about 10 minutes before you start. Take a capillary tube. These tubes are open at one end and closed at the other. And just very gently tap a little bit of the compound into the tube. Bang it on the bench to make it fall down. And keep doing this until you've got about 3 millimetres of compound in the bottom of the tube. If you put too much in it at once, you'll end up with a big amount of compound stuck at the top of the tube. You might like to try to flick it to make it go down, but if it really won't go down, you'll need to start again. So the melting point can be used to tell you what something is, but also how pure it is. The melting point range of a pure substance is between 1 and 3 degrees Celsius. You want to take the temperature just when it starts melting and when it's completely melted, and that's the range. For things that are impure, the melting point range will be up to 10 degrees. You'll probably find with this test, because you've got no idea what the melting point's going to be, that you'll need to do it a couple of times because you'll miss it the first time. Make sure when you're reading the melting point at the melting point range that the temperature's only going up very slowly, about 2 to 3 degrees per minute.
So just now, she also did the melting point determination. So that is one other things that you can also do for the physical properties determination. Okay, you can also check for the boiling point, which is what we have done in the first experiment. And then this one is I have not put it in the in our practical manual, but it also involves checking the solubility of the sample itself. Okay, and also this one involves using spectral test. So this is out of our syllabus, but then we just watch the whole videos.
The next thing to do is a range of solubility tests. The solubility tests will tell you a little bit more about which functional groups are present in your compound. If you have very polar functional groups like alcohols or amines, they'll be soluble in water. If you have acids, they'll be soluble in bases. And if you have bases, they'll be soluble in acids. Many organic compounds aren't soluble at all, however. Quite often it's difficult to see if two clear liquids are dissolving or not. So look for mixing lines, like these ones that you see here. Even if all of the substance doesn't dissolve, the presence of these mixing lines will tell you that it's at least partially soluble. If you think you have an amine because of the previous tests that you've done, don't put it into concentrated sulfuric acid because a violent reaction will occur. When you've completed the physical obs, the Lassane's test, the flame test, and the solubility test, you should have a pretty good idea about what functional groups and what elements are present in your compound. At this point, have a look at the spectra. The infrared spectra will tell you about which functional groups are present. Don't just look for what's present, but also look for what's not present, because this can tell you a lot about the structure of your compound.
So what you are seeing right now is actually the results that comes out when you did the infrared spectroscopy. Okay, so the peaks that you are seeing correspond to functional group. Okay, for example, the peaks that you see at 3000 here, okay, which is a very strong peak, would correspond to CH that comes from alkene or CH3. It could be CH asymmetric stretching and also asymmetric. Okay, this one you will learn later in year 2, SEM 2 in pharmaceutical analysis.
The second spectra to look at is the mass spec. This will tell you the molecular weight of your compound. And the molecular weight, together with the melting point or boiling point that you did earlier, will tell you a lot about which compound you have. The third spectra that you should look at is an NMR spectra. The NMR spectra will tell you about the actual structure of your compound. And you'll be able to tell, for example, if you have a primary or a secondary amine. You can confirm the presence of functional groups using some colorimetric functional group tests. There's a wide range of these tests. Just carry out the ones that you need to confirm what you know already. If you think you have an alcohol, for example, run the series of alcohol tests, which will tell you if it's a primary alcohol, a secondary alcohol, or a tertiary alcohol. Similarly, there's a range of tests for amines that will tell you if they're aliphatic amines or aromatic amines, or if the amine group is at the end of the molecule. This sort of information, once again, will be really useful in you trying to put together the structure of your molecule. The final step for confirmation is to prepare a derivative from your unknown. You need to choose the derivative that has a melting point that's really different from your starting material, and also that's really different from other derivatives. For example, if you weren't sure whether you had one phenylethylamine or two phenylethylamine, if you made the carbide derivative, they only have a difference of 4 degrees in melting point, so you still won't be able to tell those apart. Make sure your derivative that you choose has a very different melting point. Finding out the identity of an unknown organic compound like this really is quite fun. It's a bit like a jigsaw puzzle. Every test that you do gives you a little bit more information which you can put together and hopefully at the end find out exactly what the unknown compound is. Good luck.
Okay, start on that. I'm showing you this. This one is the example of doing a tolerance test. Okay, tolerance test.
Using Tollens reagent to test for aldehydes. The silver mirror test. This video demonstrates how to use Tollens reagent to test for aldehydes. This video first demonstrates the preparation of Tollens reagent. Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of Tollens reagent. Add 2 milliliters of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. Add a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as Tollens reagent. Add a small amount of sample to the Tollens reagent. Shake the mixture gently, and then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained. If the sample is not an aldehyde, the test will give a negative result. It is important that Tollens reagent should be freshly prepared. Prior to disposal, the reagent must be acidified immediately after use. The addition of acid prevents the formation of explosive silver nitride.
So that is the example of doing the tolerance test using the tolerance reagent. So if your sample is an aldehyde, it will give an positive observation. You will see the silver mirror on the surface of the test tube, okay, at the bottom of the test tube. So now for your task, okay, since you cannot do the test in the lab, okay, here in the Google Classroom, I have provide the guideline for you all on what to do. So if I'm not mistaken, there are a total of 11 tests altogether in the I think in the whole procedure, okay, not including the physical observation. That one doesn't require a test, okay, just the rest. So what I want you to do is to find the videos of each of the tests. Okay, for example, I have shown the tolerance test just now. You can find other example like Bayes test or the nitration test or saturation with bromine water test. And I want you to share the link on the comment section over here, okay, on the class comment. So there are 16 of you. So each of you have to share at least one of the tests, okay, one videos of the test. There are 11 tests. So some of you will have to uh, to say give example of the same test, but try to find different sources. Okay, um, all of the tests are available. All of the test videos, okay, the videos for all of the tests are available. You just have to find and share the link in the comment. And later on, please watch them all. So I don't want to search for it and paste it here. You might see or you might not see it. So I want you to at least try to look for it. And then in terms of the report section, so over here I have listed several compound. Okay, several compound. Each of you have to select two from this list. Let's say you select compound A, cyclohexanone, and also compound C, 3-ethyl heptanal. So take that compound and we'll go back to the manual. So this is like a reverse experiment. Okay, supposedly the identity of the compound should be unknown, but since we cannot do that, so you already have the identity of the compound. What I want you to do here in the report section is to fill up, okay, what is the expected observation that you would see from that particular compound. For example, like the first one, let's say cyclohexanone, for example. So what kind of observation if you were to do a bromine water test? Okay, if it is a saturated compound, definitely this one, the observation would be no color change. Okay, and then nitration, this one also no yellow precipitate or no yellow colored form, for example. And being a ketone, so all of the tests for aldehyde would be negative. And then for ketones, so a cyclohexanone definitely will give all positive observation for ketone, and then esters will give negative observation as well. So that is how you are going to uh, write up the report. So it's like you already know the identity of the compound. Try to fill up what kind of observation is expected out of it. Okay, there are, where is it just now? Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are uh, nine compound over here. So select two, but try to mix it around. I don't want like when you select two, everybody pick compound A and compound B. So maybe you select A and B, another person select E and F, and so on. So two of these will be considered as experiment 4. Okay, one will be considered as experiment 4, one sample, experiment 4, and the other one will be for experiment 5. So that's why I asked you to do to select two samples. Okay, so one sample for one experiment 4 and 5. The two experiments are actually the same. Okay, so there are other videos as well, like this one, the identification of unknown organic compound. So it actually shows, okay, let me show just a little bit on how the test was actually done. Okay, so you have the test tube with the sample in the test tube rack. Okay, and then you mix the reagent to it and see the observation. Okay, whether it is failings reagent or tolerance just now, and then if it requires some heating, then you have to uh, follow the procedure as well. Okay, so more or less, if you were in the lab, this is how it will be done. Okay. So this one later you can rewatch it again. So that will be all on experiment 4 and 5, the determination, sorry, the qualitative analysis of